In this video, I am going to look at how to interpret the final tableau for a standard minimization problem. So remember, for a standard minimization problem, the process is to create the dual problem, which will become a standard maximization problem. You then solve the standard maximization problem, and you end up with the final table. So that's where I'm going to pick up is, let's just say that this is our final table. Don't try to make any sense out of it. I just completely made up all of these numbers. So the final table, we want to find the value of R, S, T, and P. And so to do that, what we're going to do is we go to the very bottom row, and we're going to look at these values down here. And so to find the value of R, we take the number that is in the bottom row of the R column, which is 2, and we divide it by the p-value, 2. So R is equal to 1. S, whoops. To find the value of S, we do the same thing. We have 0 is in the bottom row of the S column. So 0 also divided by the p-value, divided by 2 is 0. To find the value of T, we find the number in the bottom row of the T column, which is 10, and we divide it by the, you got it, the p-value. And so that would be 5. And then finally, to find the value of P, we take the constant 80 and divide it by the p-value. And so 80 divided by 2 is 40. And so those are the solutions to our problem. Now, this is our p-value. It is also the c-value. The theorem in linear programming says that if a dual problem has an optimal solution, then the primal problem also has an optimal solution, and they are one and the same. So therefore, we can conclude that C is also equal to 40. And this occurs, of course, when R is equal to 1, S is equal to 0, T is equal to 5. Now, R, S, and T would be the variables in the original primal problem, which was a standard minimization problem. All right, hope you found this useful.